Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 18 and today we are going to solve a problem based on binary search trees, and the level of this question is going to be medium. The name of this question is lowest common ancestor of a binary search tree. You will get this question link in description, and you can also download this Excel sheet from description. Now, without wasting much time, let's see our question on LeetCode. So here we are on LeetCode. Let's read our question. So the question says, given a binary search tree or BST, find the lowest common ancestor LCA node of the two given nodes in the binary search tree. Okay. So question says, I have given you a binary search tree. I have also given you two different nodes. Those are node P and node Q. And you have to find out the lowest common ancestor node or LCA node for these two nodes in the given binary search tree. And here is a small definition of lowest common ancestor. But I will explain you what is lowest common ancestor by taking some examples so that you will understand this in more depth. So firstly, we will be understanding what is lowest common ancestor, and then we will think of how we can solve this problem. Okay. So before moving forward, I hope that you know what is a binary search tree. See, in a binary search tree, if I consider any particular node, then everything which is coming into the left subtree will have values lesser than the node value, and everything which is coming into the right subtree will have values greater than this node value. Okay, this is the concept of our binary search tree. So firstly, let's try to understand what is an ancestor in a binary search tree or in a BST, right? So if I consider this particular node and if I try to draw the path from this particular node up to my root node, right, then my path would look like this. Okay, this is my path from this node 6 up to my root node 10. Okay, now each and every node which is coming into this path are ancestor of 6. Okay, here you can see that we are having 5 in this particular path. It means that 5 is an ancestor of 6. We are having 10 in this particular path. It means that 10 is also an ancestor of 6, right? Similarly, if I consider any other node, let's say if I consider this node number 2, right? If I consider this node number 2, and if I try to draw a path from this node 2 up to my root node, then this will be my path. Okay, this will be my path. Now, each and every node which are coming in this particular path are ancestors of 2. Okay, here you can clearly see that we have 3 in this particular path. It means that 3 is an ancestor of 2, right? Here we have 5 in this particular path. It means that 5 is an ancestor of 2, right? Similarly, we have 10 here in this particular path. It means that 10 is also an ancestor of 2, right? So now I hope that you understand what is the ancestor, right? What is the meaning of an ancestor in a binary tree or in a binary search tree, right? Now let's try to understand what is the meaning of lowest common ancestor in a binary search tree. Okay. See, we have given two particular nodes, right? The first one is the node P, which is nothing but 2. So this is our node P, correct? And the second node is Q. It is equal to 6. So this is our node number Q, right? Now, again, I'll do the same thing. Again, I will try to draw a path from these nodes up to my root node. Okay. So if I try to draw a path from node 6, then this will be my path. Okay. This will be my path. And similarly, if I try to draw a path from node P up to root node, then this will be my path. Okay, this will be my path. Now the first node which is common in both the paths are the lowest common ancestor, right? See, in this particular path, if I'm considering the path from node P up to my root node, then the first node is 3, right? But this node 3 is not coming in this path, right? This node 3 is not coming in the path from Q to root, right? But if I consider this node 5, right? If I consider this node 5, then it is coming in the path from P to root, and it is also coming into the path from node Q up to my root. So you can say that this node 5 is common in both the paths, right? So the node which is common in both the paths are nothing but the common ancestor, and the first node which is common in both the paths are our lowest common ancestor. Now let's take one more example to understand what is lowest common ancestor. So let's say if I want to find out the lowest common ancestor of this node 12 and this node 18, right? So how I'll do that? Firstly, I'll draw the path from these nodes up to my root node. So this will be my first path from node number 12 to node number 10. and this will be my second path from node number 18 to node number 10. So here you can clearly see that we have 15 which is common, right? We have 15 which is common in both the paths, and this is the first node which is common in both the paths. Okay, here you can see that this particular node 10 is also common in both the paths, right? But we need to consider the first node which is common in both the paths. Okay, so I hope now you have understood what is lowest common ancestor in a binary tree or in a binary search tree, right? Now let's try to think of how we are going to solve this particular problem. Let's take this particular example to understand how we are going to solve this problem, right? So in the question we have given two nodes. First one is the P and the second one is the Q. So here you can clearly see that P is equal to 6. It means this is my node P, right? This is my node P, and Q is equal to 9. It means that this is my node number Q, and I need to find out the lowest common ancestor of both the nodes, right? So how I can do that? Firstly, I'll draw the path from my node P up to my root node. So this is my path, right? This is my path. And now what I'll do, I'll try to draw the path from my node Q up to my root node, right? Then this will be my path, okay? This will be my path, okay? Now, as per the definition of lowest common ancestor, the first node which is coming into both the paths are our lowest common ancestor. So here you can clearly see that this node number 8 is coming into both the paths, right? This node 8 is common in both the paths, and this node number 8 is the first node which is common, right? Therefore, this node 8 is our lowest common ancestor. So we need to find out this node 8, right? So now let's think of how we are going to do that. So now let's say initially I'm standing here into my root node and I need to find out the lowest common ancestor for this 6 and this 9, right? So what is the first task? The first task is to find out this node P and this node Q into my binary search tree. Okay, firstly I need to find out where is this node P, where is this node Q into my binary search tree. Then I will try to find out who is the lowest common ancestor, right? Okay, so if I'm standing into my root node, so what is the value of my root node? The value of my root node is 15, right? The value of my root node is 15, and I am looking for two nodes and their values are 6 and 9, right? And you can clearly see that both the values 6 and 9 are lesser than 15, right? They are lesser than 15, right? And we are here into a BST. So as per the property of BST, everything which is coming into the left subtree, right? Everything which is coming into the left subtree will have values lesser than the node value, right? So if I'm considering this node 15, then everything which is coming into this left subtree will have values lesser than 15, right? And everything which is coming into this right subtree will have values greater than 15, right? Now, here in this particular problem, we are searching for two values which are 6 and 9, and these values 6 and 9 are lesser than 15, right? Therefore, it does not make any sense to go into right subtree. Correct? It does not make any sense to go to the right subtree. Therefore, what we'll do, we will move to the left subtree, right? We will move to the left subtree. So now let's say currently I am standing here into this node 5, right? I am standing here into this node 5, and again, we'll do the same thing. We are searching for two nodes with the values 6 and 9, okay? And the current node value is 5. The current node value is 5, and we are looking for two nodes with the value 6 and 9, okay? So you can clearly see that these node values 6 and 9 are greater than 5, right? Are greater than 5, right? And as per the property of BST, everything which is present into the left will have values lesser than 5, right? And we are looking for values 6 and 9, which is greater than 5. So it does not make any sense to go to the left subtree, right? It does not make any sense to go to the left subtree. So now what we'll do, we'll move to the right subtree, right? We will move to the right subtree. So let's say now I am standing here at this node 11, right? Now I'm standing here at this node 11. Again, we will do the same thing, right? What is the current node value? The current node value is 11, okay? And we are looking for two nodes with the value 6 and 9, right? We are looking for two nodes with the value 6 and 9. So now you can clearly see that this 6 and 9 are lesser. This 6 and 9 are lesser than 11. What does it mean? It means that this 6 and 9 will definitely be in my left subtree, right? It will definitely be into my left subtree. Therefore, now what I'll do, I'll go to the left subtree, right? Now my current will be pointing here, right? Now my current will be pointing here. Okay, this is very important, right? See, currently I'm standing currently I'm standing at a node with the value 8, right? Currently I'm standing at a node with the value 8, and I am looking for two nodes with the value 6 and with the value 9, right? And here you can see that this 6 is lesser than 8 and this 9 is greater than 8, right? So now I'm not sure that this both the values 6 and 9, right? Now I'm not sure that both the value 6 and 9 are into the left or are into the right, right? You can clearly see that one value is lesser than 8. It means that it will be present into the left sub tree, and one value is 9 which is greater than 8. It means that it will be present into the right sub tree. Now whenever we are encountering a situation where I'm standing into a node and P is into the left subtree or Q is into the right subtree or vice versa, right? Let's say Q is present into the left subtree and P is present into the right subtree, right? It means that this node is nothing but our lowest common ancestor. So in this particular example, we can simply return 8 because it is our lowest common ancestor, right? And even if you observe the path, so see, firstly we were standing here into this node 15, right? Then we came to node 5, then we came to node 11, then we came to node number 8. From this node number 8, our path is getting splitted into two parts, okay? So this is the first part and this is the second part, right? So this is nothing but our lowest common ancestor, right? This is very easy to understand, right? The first node where our path is getting splitted into two parts is our lowest common ancestor. So now let's think of how we are going to code the approach which we have just discussed. And as I always say, coding is the most easiest part if you have understood the intuition and approach, right? So see, there are two ways to code the approach which we have just discussed. The very first one is the recursive solution, right? And the second one is a iterative one, right? So you know that whenever we use recursion, we consume some function called stack, which will take some extra space, right? So instead of writing a recursive solution, I will write the iterative solution, right? Because it will be more easier to understand to you and it will also take less space complexity as compared to recursive solution, okay? So let's say we are having a function, and in the function we have our root node and we also have our two nodes, right? P and Q, okay? So what's the first thing we need to do? We need to store our answer probably into any variable. So let's say I have a one answer variable which is initially equal to null, okay? Okay. Now what I need to do, I need to traverse into my binary search tree, okay? So here I'll write while my root is not equal to null, right? While my root is not equal to null, right? Now I need to check the condition, right? I need to check the condition. So firstly I'll check if the P value is greater than the root value, correct? And Q value is also greater than my root value. If this is the condition, it means that the value of P and value of Q both are greater than my current root value, right? What does it mean? It means that I need to go to the right subtree, right? I need to go to the right subtree. So here I will write solve root right, and I'll also send the P and Q, right? If this is not the condition, right? If this is not the condition, so I'll write else if the value of P is lesser than my root value, correct? And the value of Q, right? The value of Q is also lesser than my root value. It means that the value of both P and Q are lesser than my root value. If this is the case, it means that I need to go to the left subtree, right? So here I will write solve root left P and Q, right? See, if the value of P and Q are greater than our root value, we will go to the right part of the tree. And if the value of P and Q are both are lesser than my root value, then I'll go to the left part of the tree, right? But if both the conditions are not satisfied, it means that one node is in the left and one node is in the right, right? And whenever we are encountering this type of situation, it means that the current node where I'm standing is my lowest common ancestor, right? So what I'll do, I'll put my current node or my root into my answer and then I will break out, right? Then I will break out of this particular while loop, and at the end, I will return my answer, right? So this is our code for this particular approach, right? It is pretty simple and easy to understand. I hope it is clear to you. If we talk about the time complexity, then the time complexity will be equal to O of h, right? Where h is nothing but the height of our binary tree, right? And if you're talking about the space complexity, then the space complexity will be equal to O of n, right? Because apart from this answer variable, we are not using any other space, right? If you are wondering why the time complexity is equal to O of h, or height of the tree, not equal to O of n, then let me just explain it to you, right? Let's say this is our binary tree, right? Let's say this is our binary tree, correct? See, during our traversal, what we are doing, either we are moving to the left, right? Either we are moving to the left, or either we are moving to the right, correct? So therefore the time complexity will be equal to O of h, and in some scenarios the height can be equal to the number of nodes into our binary tree if we are having a straight or a skewed tree. Okay, I hope it is clear to you. So we are here on LeetCode. Let's fastly code the approach which we have just discussed. So in order to solve, what do we need? We need one answer variable which will be initially pointing to null, right? And at the end we will return our answer, right? And then we need to do a traversal into our binary search tree, right? So here I'll write a while loop, and here I'll write while root is not equal to null. Okay, now I need to write some conditions. So here I missed a closing parenthesis. Okay, so very first condition will be if the value of p is greater than my root value, and the value of q, right? The value of q is also greater than my root value, right? If this is the scenario, then what I need to do, I need to go to the right part. Okay, so here I'll write root is equal to root right. Okay, else if the value of p is lesser than my root value, right? Is lesser than my root value, and value of q is also lesser than my root value, right? If this is the case, it means that I need to go to the left part, right? So here, therefore I'll write here root is equal to root left, right? Now if both these two conditions are not satisfied, it means that we have encountered our lowest common ancestor, right? So therefore I will write a else block here, and here I'll write answer is equal to the root, right? So the current node where I'm standing is my answer, and after storing into my answer variable, I'll just break out from my while loop, correct? So this is the code. The code is pretty simple and easy to understand. Let me run this. So here you can clearly see that all the 3 sample test cases are running fine. Let me just submit this. You can clearly see that this particular solution is accepted. I have already explained you the time and space complexities, intuition, and the logic. I hope this video was helpful to you. If it was, make sure that you like to this video and don't forget to drop a comment. And if you want this type of content regularly, then make sure that you subscribe to this channel so that you will not miss my next upcoming videos. We will meet again tomorrow with a new question.